Section 8.3, we're introducing logarithms. So that is the title of our notes. Logarithms. By definition, the logarithm to the base b of a positive number y is defined as follows. So if you have y equals b to the x, all right, so y is a positive number, b is our base, then log base b, so a little subscript b, of y equals x. If you notice, all the numbers and letters match. The only difference between here and here is their order, the way they're written, and this log. So if you watch, your answer goes here. Your base becomes a little number, and your exponent becomes your new answer. The point of logs is to find the missing exponent. Okay, so when we have a missing exponent like this, we don't know what x is, we can set it up like this and figure out what x is. We're going to start by stating that the logarithm of a negative number, so when that y is a negative number, or 0, then your answer is undefined. So if y equals a negative number or 0, then your log is undefined. We're going to start by just writing things in logarithmic form. So we're starting in exponential form like this, and we're going to write it as log form like this. So this is our y, this is our b, and this is our x. So we'll write log base b, so that's 5, of y, so that's 25, equals x, which is 2. So we went here, here, and here. Let's try the next one. This is y, b, and x. So log base b, so log base 3 of y, so 729, equals x, which is 6. All right, let's try the next two. This is, that's not y. I'm already wrong. Okay, this is b, this is x, and this is y. Don't let them trick you like they almost tricked me. So log base is a half of y, so of 1/8, equals 3. Your exponent is always your answer. Exponent is the answer. So this one's answer will be 0. We'll have log, what's the base? 10 of 1. All right. In example 3, we're going to evaluate our logarithm. So we're going to figure out what the answer is. Okay, we only have the first part. Now we'll figure out what the answer is. Okay, you can do this a couple different ways, but we are going to convert it to exponential form. So, and we're going to do the opposite of what we just did. So we'll say that this equals x. So our base, let's see, this is b, this is y, and that's x. So 8 to the x equals 16. says write each side using a common base. Well, wait, what base can we use for that and that? So base means like powers. So 8 is 2 cubed times x, and 16 is 2 to the 4th. Now, by using properties of exponents, we can combine and say 2 to the 3x equals 2 to the 4th. Now set the exponents equal each other. Since their bases are the same, we can make their exponents the same. So 3x equals 4. Now solve for x, divide by 3. What does x equal? 4/3. So there's your answer. Log base 8 of 16 equals 4/3. Let's try it again with another one just to make sure we got this. Okay, so we're going to write it in exponential form. So here's our b, here's our y, and it's going to equal x. So b to the x equals y. So 10 to the x equals 100. All right, we want to write them in common bases. So I think we can write them both with base 10. So 10 to the x equals, what's 100 base 10? It's 10 squared. Good. So now we don't have to combine any exponents. We can just say that x equals 2. So your answer is 2. All right, those problems everything we've done so far will get you through number 24 on the homework. All right, 6 through 24 even. Now let's keep going. I think that this part may be on the beginning of your second page, but I think you can figure it out. It says a common logarithm is a log that uses base 10. Okay, so this one is special. It is the common one. It's the assumed. Okay, so you can write log base 10 of y. You can make that 10 disappear. There's only one s in disappear, isn't there? So log base 10 of y is the same thing as saying log of y. So anytime you don't see a base, you assume it's 10. If you don't see a base, you assume that it is 10. This log is the one that your calculator will use. There's a log button on your calculator. It is a common log, so it assumes the base is 10. All right, so now we're going to graph these. All right. Why are we doing logs with exponential functions? Well, they're definitely related. A logarithmic function which is the y equals log base b of x, is the inverse of an exponential function. All right, so inverses are reflected over what line? Hopefully you have this right because it was on your test, your last test. Over the line y equals x. Now now it's back. Y equals x. So that's the diagonal line that goes through the graphs. Also, the inverse has the flip-flop domain and range of the original. Remember that for inverses, x and y just switch. So we are going to graph a logarithmic function by graphing the inverse first, because we know how to do that. So we are going to graph the inverse of y equals 2 to the x. All right, so we need to graph y equals 2 to the x first. Okay, so I'm going to make my axes kind of off to the side here. That'll work. For y equals 2 to the x, let's make a chart, x and y. We'll go -1, 0, 1, 2, and 3. If we plug in -0, or no, not -0, -1. So y equals 2 to the -1. That's the same thing as 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. So there are your points for y equals 2 to the x. I did that in my head. You can do it on your calculator. You can do it by graphing and looking at the table. Any of that will work. So I'm going to graph it. I'm going to do it in red. So there is our function y equals 2 to the x. So now we are going to do the inverse. So y equals log base 2 of x. So remember, for inverse, you just flip the x and the y. So instead of -1, 1/2, we're going to have 1/2, -1, and then 1, 0, 2, 1, 4, 2, 8, 3. So graph those. And there is your inverse function. You see that it is reflected over the line y equals x. If you folded your paper in half on that line, the two graphs would fall on top of each other. So to get the inverse function, all you need to do is cover up the log. Okay, pretend that log is not there. You see y equals 2 to the x. So that's what you're going to graph. All right, you can use the same techniques as we have been to translate these functions. All right, because we're going to have h and k. Remember, h is always stuck with x. So here, this h makes it go right and left. The k at the end moves it up and down. So we are going to graph y equals log base 6 of x minus 2 plus 3. And if you're looking along in your book, this is actually like example 6, not example 5. Okay, so our 2 is our h, our 3 is our k. So first we're going to graph this function's parent function. So basically, without h and k, what are you going to graph? You're going to graph y equals log base 6 of x. So just ignore h and k. Please make sure you're taking good notes so that you aren't lost on your homework. You should have something that you're able to follow easily, so that is based on how good of notes you take. All right, so in order to figure out this one, we got to figure out its inverse. What's its inverse going to be? Cover up the log. What do you see? Y equals 6 to the x. All right, so let's figure out some points. Again, you can always use your table in your calculator to help you out. If we plug in 0 here, 6 to the 0 is 1. 6 to the first is 6. 6 squared is 36. Ooh, 6 cubed is 216. I didn't do that in my head. I have it written down from earlier. So now let's use this to go to y equals log base 6 of x. So instead of 0, 1, I have 1, 0. 6, 1, 36, 2, and there's no way we're going to graph 216, so I'm going to leave that point off. All right, so let's graph this one. This is all this first step. Make your axes kind of towards the bottom and towards the left. We'll make our y's go by 1s as usual, but we have to get to 36. So let's see, let's go by 3s. So this would be 6, 12, 24, oh, not 24, 18. Oh, perfect. That was just a guess. Okay. So I'm going to graph this equation. So 1, 0 is just going to be barely right there. 6, 1, 36, 2. So you can see this graph is going to be something like this. All right. Now we need to move that in order to get our actual function that we need, h and k. So h is going to make it go which way? It's going to go right 2 and then up or down 3. Up 3. So make those moves. So this point will go right 2, up, well, ooh, that I just had an interesting thought. Remember that this is not by 1s. Okay, so right 2 would make it equal 3 and then go up 3. 1, 2, 3 from there. So there's my first point. Right 2 from here is just barely over and then up 3. And then right 2, up 3, again, way out there. There is my new equation. Now these, I don't think you have to do this on your homework. Maybe so, I can't remember. These don't have horizontal asymptotes, these have vertical asymptotes. So VA is going to be x equals some number. So for the first one we graphed, our vertical asymptote is this line right here, x equals 0. And then the next one has moved over. It's your h value. Okay, so it's moved over from 0 to 2. So for the blue one, the vertical asymptote is x equals 2. Just like yesterday, how our k value gave you the horizontal asymptote for exponential, the h gives us our vertical asymptote. So So the 2 gives us the 2. All right, so these 2 examples on the back give you how to do number 36, 37, 38, 39, and 51. All right, so you have 5 problems like these. I know that they're complicated and weird, but you need to take your time and do them correctly. On Friday, the 6th, we have early release, but we are going to spend the whole time working on this assignment. So do as much as you can now and maybe a little bit tonight, and then we'll finish it in class, and it's due at the end of class on Friday.